Hi, welcome back. In this video, we are going to look at an example of composition of functions. So we're continuing to talk about operations on functions, and we're actually talking about composition of functions. So in this case, that's f of g of x. So I have an input x to my function that's first going to enter the g machine. The output of that is going to enter the f machine, and the output of that is my output of the f of g of x function. Here I have a function f of x, which is a set of ordered pairs, and my function g of x, which is also a set of ordered pairs. So I want to find f of g of x, and I want to find the domain and range of that, and I also want to find g of f of x and find the domain of that. So to start, to find my f of g of x, I need to take each of the inputs to g of x. So what's happening here is my x values are first going to enter g of x, which is the inside function. Then I'm going to get an output, and then it's going to enter the f function. So I start with x equals 8. I'm going to take 8. It's going to enter the function g, and so I am going to find g of 8. Well, g of 8 is equal to 15. So now I'm going to take that output of 15, and it's going to go into the f function, and I am going to get 11. So this gives me the ordered pair 8, 11 for my f of g of x function. I'm now going to take an x value of 5 and enter it into the g function. So if 5 goes into the g function, 1 comes out of the g function. 1 will go into the f function, and if 1 goes into the f function, 8 comes out of the f function, giving me an ordered pair 5, 8. So I start with what entered the function and end with what exited the final function. And then I'm going to look at an x value of 10. So I say g of 10. So I look, g of 10 is 14. If 10 enters g, 14 comes out. If 14 enters f, 9 comes out. So that gives me the ordered pair 10, 9. If x is equal to 9, 9 enters the g function, 0 comes out. If 0 enters the f function, 13 comes out. So I have the ordered pair 9, 13. These are the only 4 possible inputs for this function. Because g of x is just a set of points, the domain of g is 8, 5, 10, 9, and the range is 15, 1, 14, 0. That means that only values 8, 5, 10, and 9 can enter the g function and have something come out. No values other than these 4 will work. It would be like if I had a machine that makes sweaters, and instead of putting in yarn, I put in flour, I wouldn't end up getting a sweater. The machine would just break. So if I enter any of these things, anything other than these 4 values into my g function, the function's going to break. Similarly, there are restrictions on what can enter and exit the f function, and that is 1, 0, 15, and 14 are the domain of f, and the range of f is 8, 13, 11, and 9. So my f of g of x function is the set of ordered pairs 8, 11, 5, 8, 10, 9, 9, 13. The domain of this function is the x values of that. So that is 8, 5, 10, and 9. Those are the values that have the ability to go into the function and have something come out. And the range of the function is 11, 8, 9, and 13. Those are the values that are possible to come out of the function. So then I'm going to look at the g of f of x function. I'm going to work through this the same way. However, our function works backwards. So our x values are going to go into f. Then we're going to get f of x values out. Those f of x values that come out will then go into the g of x function. So we're going to work the other direction. So I'm still going to start with an x value. So I'm going to start with x values from my f function. So I'll start with x equals 1. So f of 1 is equal to 8. So if 1 goes into the f function, 8 comes out. If 8 goes into the g function, 15 comes out, giving me an ordered pair, 1, 15. If x equals 0, f of 0 is equal to 13. 13 in the g function does not exist. DNE stands for does not exist. So what ends up happening here is if I put x equals 0 into the function, it makes it through the f function, it enters the g function, and then it has a malfunction. So it's able to pass through f, but not through g. So x equals 0 will not appear in the domain of my g of f of x function. Next, we'll look at x equals 15. So that gives me f of 15 is equal to 11. 11 goes into the g function, and again, it does not exist. 11 cannot enter the g function. There is no output for the input of 11. Then we'll look at x equals 14. So if 14 goes into the f function, 9 comes out. If 9 goes into the g function, 0 comes out, giving me the ordered pair 14, 0. So in this case, g of f of x is equal to the set of ordered pairs 1, 15 and 14, 0. The domain of this function is 1 and 14, and the range of this function is 15 and 0. So now I want to ask the question, is this commutative? So is this operation composition of functions commutative? So that means if I'm going this direction through the machine, is it the same as going this direction through the machine? And what I end up seeing is that f of g of x is not equal to g of f of x. They have different domains, they have different ranges, and the functions themselves are just a different set of ordered pairs. That means that this is not a commutative operation. Because this is not commutative, order matters, and we need to think about which function is inside the other. The key thing to think about is that we're going to work from the inside out. So whatever is on the very inside, that's our first input. So here, x is our first input. It goes into the g function. G of x is our input into the f of x function. And I could even imagine a situation where I had f of g of h of k of x. And in this case, that would mean that I have x as the input into the k function, k of x as the output that gets put into the h function, h of k of x is the output here that gets to be the input of the g function, and then g of h of k of x is the input into the f function. So these can nest themselves. Think about going all the way in, and whatever is the furthest in function, that is the first function that you're going to want to use.